Hi, this is Dr. Brandon Lujan with West Coast Retina. Today on OCTMD, let's do a tutorial on en face OCT imaging, looking at this eye with macular telangiectasia. Just from the high definition scans, we get a nice look at the horizontal and vertical images, and we can see that there's a defect in the center of the fovea. The photoreceptors are abnormal both in the ONL and the ISOS junction. If we click on that again and we enlarge, we right click, we can get rid of that pink navigator, and we'll scroll through the images here. So we can see that the loss is not just in the center, but exists over a larger area. Let's quantify that by going to the Advanced Visualization option. From the cube scan, this screen comes up. So here you have a horizontal and a vertical cross-sectional images. This is an en face rendering. By default, it's set to slice, which is the least useful en face mechanism. It's showing you a slice of data through this yellow line. So you could move that around and see what's happening. The problem with this slice is that you're only looking at a single pixel width, and it's not conforming to the geometry of an eye. It's orthogonal. So we have options. In this case, we're looking at photoreceptors. The most similar anatomy between our options of ILM and RPE is the RPE. I'm actually going to change the color. This is very useful. So this here you can change the color of the line you're going to be using. So I always use this red color. It stands out better. I can turn off the normal segmentation lines and still keep my segmentation. So now we're seeing that. It's showing that we're doing a 41 micron thick slab. We have control to adjust that. Empirically, I've learned that around 43, 45 microns gives you a nice ISOS slab, and we're going to elevate that to the level of the ISOS. We can move this out of the way and scroll through B-scans just to see that in fact we are encompassing that layer everywhere. And then when we go back to the en face image, we can see that that region is well delineated. An important thing to be able to do with en face images is adjust the brightness and contrast, because often you're not seeing what you want to see very well. So you're choosing that with the right click and then moving both back and forth, up and down to get to the optimal level. And when you get there, you can see that this is well delineated now. If there's any ambiguity, like in this area where you don't have a sharp border, you can bring the slice navigator back and you can actually go right to that spot. And then go back to your B-scan and see what's there, just to confirm that that is a real anatomy. Similarly, you can go the opposite way. Here we're showing the ISOS boundary. By going there, we can now go back to the en face slab and confirm that that's accurate. So if you were doing fine measurements, the ability to be able to see both the cross-section and the en face image is very useful. Other pathologies are going to use different contour lines. The ILM is sometimes useful, depends on the pathology. The slab is sometimes important to use if you don't have something that respects these anatomic boundaries. You want to print an image or save an image, you can just right click and choose save. Otherwise you can do screenshots. It's important to always save a cross section and the en face image together as a set. You always want to be able to go back and recreate this image. You will not be able to do that if you don't save the B-scan, and it's hard to interpret just from the en face image what you're seeing. That's all for now. Thanks for watching. Have fun with en face imaging.